Okay, so we're going to look at one more trig identity problem. We're going to look at another example where the directions ask us to prove or disprove. And here's a big mess of stuff. Tan x plus cotan minus x over tan x minus cotan minus x equals sine squared minus cosine squared. It might be an identity, it might not. We're going to try to prove or disprove, and in our previous video we had these steps laid out for us. And so we're going to start here by applying step one. We're first going to try to prove this identity, and if we're able to prove it, we're done. If we're not, then there's more work to do. So let's see if we can try to prove. And here I'm going to use my shorthand again, where I'm going to write left-hand side, right-hand side, so I can refer to these two parts of this equation. Now, there's a big mess of stuff on the left-hand side, so I'm going to work from the left-hand side and see what I can say about tan x plus cotan minus x over tan x minus cotan minus x. And right off the bat, I want to get that minus x out of cotangent, and that has to do with the the even and odd function properties of some of the trig functions. Cotan minus x is going to be equal to minus cotan x, and I'm going to say you should verify this, or either convince yourself, or that was really another part of the course where we talked about how we could verify this. So verify that to convince yourselves. Sometimes the minus sign goes away, like with cosine. Sometimes the minus sign pops out. If we think of cotangent as cosine over sine, it's easy to verify. It's not too hard to verify that cotangent minus x is minus cotangent x. So cotangent has the odd function property similar to sine. So I can rewrite this left-hand side right off the bat by applying this odd function property and say tangent x minus cotangent x over tangent x. Now I'll get minus a minus, right? So it'll be plus cotangent x is my left-hand side. Now I'm trying to, so that I like that a lot because I got rid of those minus x's in the cotangent. Now I'm trying to get something that looks like sine squared minus cosine squared. So what I can do here is, one strategy is to rewrite these functions all in terms of sine and cosine. It's going to be kind of a big mess if I write this out. I got sine x over cosine x, that's one tangent, minus cotangent is cosine x over sine x, all over sine x over cosine x again, plus cosine x over sine x. So I have this thing called a complex fraction, a fraction of fractions. It's a big mess. What I'm going to do whenever I get a complex fraction, I like to write it out as a division problem. And what I can do is I can take everything on top divided by everything on the bottom, and when you convert to division, you take the numerator divided by the denominator. So we're actually going to write it out sideways, left to right. And so what do I have here? I have the numerator sine x over cosine x minus cosine x over sine x divided by everything in the denominator, sine x over cosine x plus cosine x over sine x. So give yourself lots of room, spread out, and because I write big and I need lots of room to work through these more complicated problems. Now there's something missing from the way I wrote this, and I'm just purposely pausing here to get you to think about it a little bit. There's grouping that's understood in that complex fraction, and I have to indicate it here. I have to write parentheses around this first subtraction and parentheses around the two fractions that came from the denominator, because it's understood those are grouped together. I got to do the subtraction inside here, the addition inside here, before I can do the division that occurs in between. To do the subtraction and the addition, I need a common denominator in each case. And for these two guys, I have an LCD of cosine x times sine x. I got to multiply those two denominators together. And for these two, I actually have the same common denominator, cosine x sine x. So I'm going to write this out in detail. If you could do some of these steps in your head, that's fine, but I also think there's nothing wrong with just writing it out in detail if that helps you stay organized about things. I'm going to, in the first parentheses, I'm going to take sine x over cosine x. And to get that common denominator, I need to multiply by sine x below. In order not to change the value of the fraction, I have to multiply by sine x above also. So that first fraction I'm multiplying by sine x over sine x minus cosine x over sine x. I'm going to multiply by cosine x over cosine x. So that each of those fractions will have the common denominator divided by, I'll start working on my other, my addition here. In the same way, I'm taking the first fraction, sine x over cosine x, and I'm going to multiply by sine x over sine x to get that common denominator, plus cosine x over sine x. I'm going to multiply by cosine x over cosine x. So it's quite a mess. Okay. Now, again, I'm not going to leave any step out because I want everybody to see what's going on here. So now my first fraction here has become sine x times sine x is actually sine squared x over cosine x sine x minus cosine x is cosine squared x over cosine x sine x, or sine x cosine x, either way, divided by, so that was this fraction. This fraction is sine squared x over cosine x sine x plus this product is going to be cosine squared x over sine x cosine x. Okay. Now I'm ready to combine fractions here. I can subtract sine squared x minus cosine squared x all over the common denominator written just one time. And at this point, I don't need the parentheses anymore because I've gotten down to one fraction. Divided by, here I'll have sine squared x plus cosine squared x over the common denominator, cosine x sine x. And now I'm finally ready to do the division, right? I have sine squared x minus cosine squared x over cosine x sine x times cosine x sine x. So I'm flipping the second fraction over sine squared x plus cosine squared x. And I can think about the multiplication now. Now, notice I can cancel a cosine x with a cosine x, a sine x here with a sine x, because those are factors. I cannot cancel a sine squared with a sine squared, or cosine squared with a cosine squared, though, because of the plus or minus signs in between, right? Sine squared and cosine squared are not factors. But I almost got, let's not forget about where we were trying to get to here. Back in our original problem, we were trying to get to sine squared minus cosine squared. Well, I can see that sine squared minus cosine squared in the numerator right here, right? But then what about this sine squared plus cosine squared? Well, from our most famous trig identity, the Pythagorean identity, for any x at all, sine squared plus sine squared x plus cosine squared x is always equal to 1. In other words, we have sine squared x minus cosine squared x over 1 times 1 over, I can just write 1, because sine squared x plus cosine squared x, whenever we see that occur in a trig problem, is equal to 1. You can replace that sum of squares with the 1, and so I think we got it. We got all this stuff is equal to just sine squared x minus cosine squared x. And again, I just want to repeat the fact that we used over here, maybe I'll write it here on the side, sine squared x plus cosine squared x is equal to 1 for all x. When we see that sum of squares of sine and cosine, we can just replace that expression with 1 because it's equal to 1 for all x. We got our right-hand side. So we have proved the identity. We have proved the identity. So step 1 does it. We're totally through. This is exactly the same as verifying an identity. And I'm going to try to lift the camera a bit here so I can get the whole problem in a shot. And that's actually our last example of trig identity problems. There's one note I want to make. If you are working through the homework problems, so 9.1 exercises, homework exercises 40, 41, 42. The directions might be a little bit unclear. If not an identity, make a small change, and you can make a really small change. There's a way to do it in those. Make a small change to turn it into an identity. That's basically what the textbook is saying. I'm not going to do one of these in video, but I think if I just give you these instructions, that's enough for you to go on. All right, that's it.